Okay, now we are going to take up one more example wherein if a regular pentagonal lamina of 25 mm sides is resting on one of its sides on HP while the corner opposite to this touches VP. If the lamina makes an angle of 60 degree with HP and 30 degree with VP, draw the projections of the lamina. So this is very similar to the example what we have considered the last problem wherein a regular pentagonal lamina of 25 mm side is resting on one of its corners on HP. So now he says the side is resting on HP. Even though when the corner was resting on HP, the initial position was the same, and here also the initial position is same. This is because that is the side opposite is always a corner. So whether it is corner resting on HP or the side resting on HP, always the initial position will going to remain the same. And here the edge is one of the edges is perpendicular to VB. So a regular pentagonal lamina of 25 mm side is resting on one of its sides on HP. The side resting on HP has to be perpendicular to VP. So this is the condition. And since one of the sides has to rest on HP, first we make all the sides should rest on HP. So that means if all the sides are resting on HP, we can see here all the sides are resting on HP. That is being shown here also. So obviously that will going to be parallel to HP. Since it is parallel to HP, so I am getting the true shape. So where is the true shape? True shape will be on horizontal plane. So that is the true shape what we have written in the horizontal plane, which is here below XY line. And once it is parallel to HP, the surface once it is parallel to HP, so obviously that surface will going to be the perpendicular to VP. So that is the reason why we are getting a horizontal line here. So in the next condition or in the next position, if you go see that, so is resting on one of its sides on HP and the lamina makes an angle of 60 degree with HP. So that means he says the surface inclination makes an angle of 60 degrees. So the initially when the lamina was parallel to HP, so now we are making the surface of the lamina is inclined at an angle of 60 degrees to HP. Once the surface makes an angle of 60 degrees with HP, but still that lamina is perpendicular to VP, so that is the reason why we are getting a line here. And we can see since the side is resting on HP, so you can see AE is resting on HP, which is in the when you look from the front view, it will going to be A dash and E dash will be on XY line. So that is what the A dash is on XY line. And since the surface of the lamina is perpendicular to VP, so you are getting a line here. In the surface inclinations can be seen once if it is perpendicular. So the surface is inclined to HP, that inclination can be seen in the vertical plane. So in the second position, first you draw a inclined line at an angle of 60 and measure the length of A dash to C dash with A dash as center, cut an arc on this. Then measure the distance from A dash to B dash with A dash as center, cut an arc here. So that you will going to get A dash, B dash, C dash, D dash, A dash. And once the position has been changed, to this you need to write the top view. Once you look from the top view, draw a vertical projector from A dash and draw a horizontal projector from A to get this point. Similarly, you transfer all these points or you project all these points to the top view to get the corresponding points in the top view. Now the edge is resting on HP and the surface is inclined at an angle of 60 degrees to HP. Next, while the corner opposite to this touches VP, if the lamina makes an angle of 30 degree with VP, draw the projections of the lamina. So here, while the corner opposite to this touches VP, so which is the corner opposite to this means it is the edge. So which is this edge, which is AE. Because that is the edge which is resting on HP, the corner opposite to the side, which is that AE, which is resting on HP, is touching VP. So now the corner is in front of VP. So now we need to touch the corner on the XY line or it has to touch the top view. So here we can see here when you look from the top view that vertical plane will be here. When it is projected, it will come on XY line. So that is the reason why you are getting a point here which is on the XY line. And now the second position, that means I am rotating the lamina which was inclined to HP at an angle of 60 degrees, and that lamina I am rotating by an angle of 90 degrees. So here the surface which was inclined at an angle of 60 degrees, that lamina I need to rotate such that the top view of that point, which is C, has to rest on VP. So you need to rotate this by an angle of 90 degree. So when you want to rotate, you have to rotate only in anti-clockwise direction. You cannot rotate clockwise. That is basically because when you rotate the clockwise, AE will be nearer to the XY line if you rotate clockwise. But since the corner has to touch VP, so you will have to rotate only in anti-clockwise direction. Once you rotate in anti-clockwise direction, the C will going to be on XY line, and then B will come to the right side, and D will going to come to the left side. So when you are rewriting this sketch, you first you consider any point on this and draw a vertical line. Measure the distance from this point to this, and from here you mark that point. At this point you have a perpendicular to this particular line, so you draw a perpendicular to that line and measure the length from this point to this point by using compass and draw from here to here. Don't measure the distance from C to D, it's not correct. So we need to measure the distance from the intersection point of this to D, and from the same point you cut it here. Similarly, measure the distance from this point to B, and from this point you cut it. Again you measure the distance from C to this point, and from C you mark that point. Again you draw a perpendicular, because this line is perpendicular to this, so naturally from this for this line you draw a perpendicular, and then measure the length from this point to this point by using compass. Again from here you cut it. Similarly, measure the length from this point to A, and from here you cut it on this side to then mark them and join A, B, C, D, E. And then to this position you write the front view. Once you write the front view, draw a vertical projector from A and draw a horizontal projector from A dash to get this point. Similarly, draw a vertical projector from E and draw a horizontal projector from A dash to get this point. Similarly, draw a vertical projector from B and draw a horizontal projector from B dash to get this point. Similarly, D, draw a vertical projector from D dash, you will get this point. Similarly, draw a vertical projector from C and draw a horizontal projector from this, so to get this point. So now we have the surface, so the corner opposite to this touches VP now. So the corner opposite to the side is touches VP. So we can see the edge is the side is resting on HP, the corner opposite to the side is resting on VP. But still the surface inclination makes an angle of 30 degrees with VP is not shown. That is basically because when the surface is inclined to VP here and the surface is inclined to HP here, so obviously that surface has to be perpendicular to VP, perpendicular to the profile plane. Once it is perpendicular to the profile plane, I can see the inclination with respect to HP here, and I can see the vertical inclination with respect to VP here. So that is the reason why you are getting here, this is the inclination with respect to VP and this is the inclination with respect to HP. The inclination with respect to HP is already shown here, which is 60 degrees, and when you write the profile view, you can see you will going to get a line because the lamina is perpendicular to the profile plane. Now you can see the edge is resting on HP and the corner which is touching VP. Since the edge is having an angle of 60 degrees here, so that means the surface is inclined at 60 degrees to HP here and 30 degrees to VP, we are going to get automatically, because the sum of these two angles should be always equal to 90 degrees. So how to visualize this? You have to see from here, that is from this side, if you measure, that is from the left side view, if you are observing, C is near to the observer, C double dash is visible, D is near to the observer, D double dash is visible, A is near to the observer, A double dash is visible, E double dash is visible. A is away from the observer, A double dash is invisible. B is away from the observer, so B double dash is invisible, and C double dash is always visible now. So in the similar way, if you look from here, C dash, D dash, E dash is visible, and B dash, A dash is invisible. So here you are going to get A double dash and B double dash is invisible. So how do I know that the problem is right? The side is resting on HP, the side opposite to the corner, the side which is the side AE is resting on HP, and the side opposite to the corner is C is touching VP. The surface makes an angle of 60 degree with HP and 30 degree with VP, and the lamina itself is 25 mm is the position. So this is how I can analyze that my problem is right.